Hello everyone, welcome to the first section in the last chapter. This is chapter 6, all about areas and volumes. So today we're going to talk about areas. Areas in the plane. How do we find the area between two curves? That's what 6.1 is all about, finding the area between two curves. Well, what do we know finds area? In calculus, to calculate area under a curve, I use the integral. So I have two curves. So how could we do this? Well, the area under this curve would be 2 minus x squared. The area under this little curve be negative x. So how do I calculate the area between these two things? I'm going to subtract these two. And instead of doing them as two separate integrals, I'm going to write it as one integral. I'm going to do the top area, or the big area, 2 minus x squared, minus the small area. We're missing one thing. What am I missing? I'm missing bounds, where I'm going to integrate this from and to. Well, the bounds come from this point and this point. So I need to calculate those 2 points. What about those 2 points? Well, it's where these two equations are equal. So I'm going to do a little bit of algebra, and I'm going to set 2 minus x squared equal to negative x. So 2 minus x squared is equal to negative x. This is a quadratic equation. It needs to be equal to 0. I'm going to move everything to this side to make my x squared positive. I'm going to factor. And this will tell me that x equals negative 1 and x equals 2. So now I know my equation, my integral that I want to set up. It's the integral from negative 1 to 2 of the top function minus the bottom function. I've set up the problem. I'm going to rewrite this. Minus and negative is positive. So now I have this integral. Again, it comes from the top function minus the bottom function. Let's integrate. If I integrate this, I get 2x minus 1/3 x cubed plus 1/2 x squared. I don't put a plus c because it's a definite integral, which means I still need to evaluate it between negative 1 and 2. Start first with plugging in 2. If you plug 2 into this problem, you're going to get 10/3. You guys can do that in the calculator or be able to do it by hand as well. Minus, if you plug in negative 1 to this problem, you get negative 7/6. And if you subtract 10/3 plus a positive 7/6, you're going to get 9/2 or 4.5. So once you set up the integral, the rest is just calculus. And how do you set up the integral? Top minus bottom. In this case, minus and negative makes it positive. If we want to make sure of it, I'm going to go to y equals and plug in my integral. Remember, half the test is calculator, so being able to do this is important. Second trace 7. The bottom is negative 1. The top is 2. And look, my area is 4.5. So I did it correctly. Always double check on a calculator if you're allowed to. Use your calculator as much as possible. What's the big idea here? The area between two curves is the integral between the two intersections of the top one minus the bottom one. Or you can think of it as the big one minus the small one. Sometimes I like to think about it as the far one minus the close one. Top minus bottom or big minus small. Okay? We're going to do a lot more examples in class. But for now, let's go on to a different type of problem. What about a function like this? I have the square root of x, and I have x minus 2. But what do you notice here? This function is on top to here, and there is no function on the bottom. So 0 would be your bottom function. But then here, it switches. Now this is the bottom function. So I could, if I wanted to, split this into two problems. The integral of the square root of x minus 0 plus the integral of the square root of x minus 2. And I would find my bounds, and I could do it that way. Why did I have to split it into two problems? Because yes, the square root of x is always on top, but x minus 2 isn't always on bottom. It's on bottom to here, but then 0 is on bottom here. Can we think of a better way to do this? Instead of doing top minus bottom, is there a different way we could do it? Yeah. Instead of looking at the top and the bottom of the function, the positive and the negative of the function, or the highest and the lowest, let's flip it sideways. Let's talk about the furthest right minus the furthest left. So I'm going to go right minus left instead of top minus bottom. So I'm going to go sideways. Instead of going this way, I'm going to calculate it this way. But that changes something. Now, I use dy. I don't want x's anymore. I want y's. Because I'm going sideways, I want to use only y's. What do I mean by use the y's? Well, let's think about it. Those are my two equations, y equals and y equals. Is there any way I can rewrite them so that they're not y equals? They're x equals something with a y in it. Yeah, that's easy. This is y squared. This is y plus 2. So now, let's set up our integral. Instead of doing top minus bottom, because there's two different bottoms, let's do the right side minus the left side. I'm not going to do x minus 2 because that's x's. Let's do y plus 2. Minus, I'm not going to do the square root of x because that's the x's. I'm going to do y squared. dy. Now instead of doing top minus bottom and doing two different integrals, I can do right minus left and just do one integral because it's one right side and one left side. What am I missing? I'm missing the bounds. And just like before, how do I find the bounds? I set these two things equal to each other. Y squared equals y plus 2. Y squared minus y minus 2 equals 0. Hey, this looks familiar. It's just like the problem we just did. Y minus 2, y plus 1 equals 0. Y equals 2, y equals negative 1. So now my bounds are negative 1 to 2. This is y plus 2 minus y squared dy. And that problem should look familiar. It's the same problem we just did, but with y's instead of x's. So let's integrate. This is 1/2 y squared plus 2y minus 1/3 y cubed, evaluated from negative 1 to 2. If you plug in the 2, you're going to get 10/3. Minus, plug in the negative 1, you're going to get negative 7/6, which is again 9/2. So what's different about this type of problem? In this type of problem, I did right minus left because my functions look better that way. Okay? In general, what's the rules? Sketch the curve and determine which is the top or the bottom or the big or the small. Decide if you want to use vertical or horizontal strips, and we're going to do whichever one is easier to write, or which one lets you integrate the fewest times. Write your integral, top minus bottom or big minus small. Find the limits of integration, those are the bounds, and then integrate to find the area. This section is pretty simple. It's just about practice. When is an example of some time that you might want to use right minus left instead of top minus bottom? Well, let's say that you had a graph that looked like this. I have a parabola, and I have a line, and this is the area that I want to find. Is this better to do a top minus bottom or a right minus left? Well, inside that area, there's always a top and there's always a bottom. So this is better to do top minus bottom. And if that's the case, I need all x's and I need a dx in the integral. Everything will be x's and everything will be an integral. But what about a problem like this? And yeah, we will see problems like this that have sideways parabolas in them. How about now, if I want to find this area? In this case, because the bottom changes, sometimes it's the blue and sometimes it's the red, I want to do right minus left. And I want everything to be all y's, and I want it to be dy. Okay? Sometimes it doesn't matter. For example, what if I have a graph like this? And let's call this y equals x squared. And this is the line, x equals 3. And this is the area I want to find in here. Okay? First thing, let's find this intersection down here. That's 0, 0. What's this intersection up here? Well, if x is 3, y must be 9. Do I want to do top minus bottom, or do I want to do right minus left? You can do either one in this case, and neither one is easier. If I wanted to do top minus bottom, the top function is x squared. There is no bottom function. Yes, there is. What equation is this? Y equals 0. What are the bounds in this case? Well, the bounds are the x values. Starts at 0, goes to 3. That's one way to do this problem, and you can do the calculus from there. What if I wanted to go right minus left? Well, you can still do that. We're going to use dy's. What is the right side of this function? It's 3. Minus, what's the left side of this function? It's x squared. But I can't put x squared into a dy problem. So x equals square root of y. So it's 3 minus square root of y. What are the bounds? Well, I look at the y values now, 0 and 9. So here's an example where either way works. You just get to choose which one you want to do. Personally, I would do this one. It's much, much, much easier. But this is still possible. As always, guys, if you have any questions about area, please let me know. Area is the foundation for what we do next, which is rotational volume. So if you don't get this, you're not going to get rotational volume. If you have questions, come see me before school, after school, or during study hall. Thanks, everyone.